Hello and welcome back to the February update for the Tau team. You're here with me, Follow. Without further ado, let's get into Karim for the overview this month. Over to you, my friend.
Thank you, Fola, and welcome everyone to the Tau Development Team Update for the month of February 2026. Andrei last month continued working on hardening the Tau runtime. He added the safe recovery mode that can force clean Genesis restart after repeated failures or suspected corruption. He refactored the state restoration to keep the change state and Tau synchronized during restarts. He also improved the reliability by tracking the Tau engine state, adding explicit readiness signaling, and separating timeout errors from real process errors. Then, on the network and security side, he enabled the loading of minor keys from files and added connection and rate limit controls for stability and DDoS resistance. He also handled client disconnects cleanly and added WebSocket support and a non-blocking background thread. Finally, he made transaction validation deterministic and non-polluting by restoring prior state after checks, enforced canonical caching, signing consistency between backend and web wallet, and pushed some web UI improvements as well as some Android related updates. David, on his end, this month worked on some core Tau issues that should help us with performance improvements, but he also spent quite a bit of time resolving many of the outstanding issues on GitHub. So among the improvements he made this month is he added a heuristic into the prenexing algorithm to eliminate existential variables whenever possible, to substitute the quantified variables by a term. This is especially useful in Bitvector case where the elimination procedure is quite expensive. We hope this will bring some significant performance improvements. He also improved or replaced the colon equal in the input-output stream definitions uh, simply with the equal sign, just as we did elsewhere in order to have a more consistent grammar throughout the code. He also refactored the type interface, extracting several lambdas into proper functions to make the code more readable. And he verified several type inference issues that Andrei encountered some time ago. And it seems like they are all resolved now with the latest Tau. And now he's wrapping up the improvements of error reporting in the type interface. On the bug fixing side, he resolved issue number 58 from GitHub, which was regarding type input-output stream definitions. Now the target stream is probably typed during the transformation phase and before type inference. This issue was causing a crash in the REPL in several test cases. He also fixed issue 54, which is related to improper handling of input-output stream definitions without target stream. The solution was partially described by the Darklight X and by PT7K, but required further changes on his part by properly handling types in these type definitions. Him and Lucca, so David and Lucca worked to resolve issue number 41, which is also related to another issue that Lucca found, and they both had to do with improper function type inference. This fix was necessary to have proper matching of functions and predicates. David also fixed issue number 52, which was related to improper type inference as well. And the formula was general and specific bit vector elements. The type was not properly propagated. He also resolved issue number 44, which was related to improper use of the CVC5 function in the formula to bit vector transformation. He also took stock of all remaining issues on GitHub to see which ones can be readily closed. For example, issue number 51, he looked into it, but we decided not to support recurrence relation override. So instead, he added a warning in the code whenever that situation arises. and we left the issue open for full resolution at a later time. Lucca, on his end, he finished the implementation of advanced Bitvector constant simplification. Then he enabled type inference based on previous function definitions. He also improved the specification partitioning algorithm during interpretations, which should result in marked performance improvement for Tau when it is fully implemented. He fixed an issue with handling of the negation of constants, as well as another issue with the equality reasoning breaking partitions. And finally, he spent a lot of time and a lot of discussions with Ohad regarding his latest research on Boolean function quantifier eliminations, which will be useful for the tables implementation. Tomáš, on his side, he uh, finished a major feature implementation, which we call the Tau C++ API. It's more of an internal API, really, but it was necessary for implementing the Tau Python bindings on top of the C++ API, which allowed Andrei to greatly simplify the TauNet runtime. So he no longer has to go through the REPL in order to communicate with the Tau runtime. So this has made the TauNet node much easier to understand and much easier to deploy, and much more robust as well. Tomáš also made sure that all these libraries build an artifacts, so they all build on macOS. He finally looked on GitHub workflows and made sure to enable all our building of packages again. So now that all of our tests are passing again, and now we're back in good shape, basically, with the building and testing of packages. That's it for the development team overview for this month. Back to you, Fola. Thank you.
All right, fantastic. Thanks, Karim. And I'll pass it over to Andrei straight into it with blockchain update.
Hello everyone. Last month I was focused on making Tau TestNet Alpha available to public. For this I had to make several significant improvements to the node runtime itself. I had to make sure that it handles errors correctly, crashes of Tau interpreter correctly, ensure that it won't freeze under the load. Also, I had to harden networking. I introduced per node limits and network communications limits, so our main node won't be overwhelmed by the load. Also, I've introduced mining keys, since we're now at proof of authority consensus mechanism. We need to distinguish the miner and proof of authority miner from other nodes. So I introduced miner key, and all blocks now signed with a miner key. Also, I had to improve the validation, transaction validation. Now it's more deterministic. If there is new rules, it will validate new rule against the Tau state. Then it will apply all custom inputs, and then it returns Tau state to the initial state of the current block. And as you all have seen already, I made a web wallet available on our website testnet.tau.net. From this web wallet you can send transactions, write rules, check your balance on your local node, and soon it will be available to connect to our main node directly. That's all for now. Next month, I'm focused on making direct Tau bindings available, since Now we run Tau interpreter from the Docker, and I'm working on making a direct connection through library bindings available for communication with Tau. It will make the whole communication significantly faster and more reliable. So thank you so much. See you next month. Bye.
Excellent stuff, Andrei. Thank you. And Lucca, over to you.
Thank you, Follow. Hello, everyone. Thank you for joining. So this month, I finished the implementation of the advanced Bitvector constant simplification. This work was started in December, and now it is done. And this concerned, for example, if you have x minus a constant minus y minus a constant, that you can simplify this to x minus y minus a constant. And these simplifications are now enabled. Furthermore, I worked on integrating previous function definitions into the type inference algorithm. So now if in REPL you have a function definition defined and you use the symbol in the specification, the type inference algorithm will try to use the type from this definition. Previously, the definition was only matched if you explicitly type the function symbol again in the specification. Furthermore, I've reviewed together with Ohad an approach to the Boolean function quantifier elimination for the past week. And besides this, I have mainly worked in fixing some issues and an improvement to the partitioning algorithm during the interpretation of a specification, where we now don't recalculate basically the realizability check for parts of the specification that were already calculated. And that's been my month. Thank you very much, and I'll give it back to Follow.
Excellent. Thank you very much. And let's pass it to David. Hit it right, my friend.
Thank you, Fola, and thanks everyone for listening. This month I have made several improvements in the Tau language, and also I have been working on the GitHub issues opened by the community. Regarding the improvements, I have added an heuristic into the anti-Prenexing algorithm to eliminate existential variables when we could substitute the quantified variable by a term not including the variable to be eliminated. This is especially useful in the case of Bitvectors when we want to eliminate quite expensive expressions. We hope this will improve the overall performance. I have also changed the grammar to use the same notation for the definitions of streams and also recurrence relations. And I have refactored the type inference code in order to simplify several lambdas that we have used inside functions, so everything is more readable. Regarding the issues fixed, I have fixed an issue regarding the typing of input-output streams definitions. Now the target stream is properly typed during the transformation phase, before type inference. This also fixes crashes that we have seen in the REPL and are related to the issues 58 and 54 commented later. I have solved the issue 54 related to improper dealing with input-output stream definitions. I have also solved issue 58. This issue was related to how the file streams are handled. When we define an string, data is getting done properly. A partial solution was proposed by the LarLiX, but further work and changes was needed to fix this issue. I have also solved an issue detected by Lucca regarding improper function type inference during type inference. This issue was of particular interest as it was necessary to have a proper matching of functions and predicates. This fix, in conjunction with all the work that Lucca has done, solved issue 41. I have also solved issue 52. It was related to the improper type inference in a formula when with general Bitvector elements and specific Bitvector bit sizes. The type wasn't properly propagated in this case. I have also solved issue 44. It was related to use of an improper CVC function in the formula during the Bitvector transformation. And also I have been checking the type inference in several cases that Andrei found troublesome time ago. Everything seems to be working fine in this regard. Apart from that, I have also checking other GitHub issues that are pending to see if they are still valid or they require further work. Among them, issue 51 is related to we don't support recurrence relations override. I have had a warning in the code, so when we detect that someone is trying to override the definition, he could get some information that it's not supported. Now I'm wrapping improvements in the error reporting and handling in type inference, so the errors that the user get in the Tau language are more, let's say, informative. And also I have been taking a look to the workflows and the creation of artifacts to enable them again. Tomáš has been leading these tasks, but it's something that all the team needs to take a look to be sure that everything is working fine. And that's all for my month. Thank you all for listening, and back to you, Fola.
Awesome. Tomáš, over to you.
Thank you, Fola. Hello, everyone. Recent month, I've been working on finishing initial implementation of Tau API to allow simple programmatic use of Tau. This required to do some refactoring of I/O context, which contains information about input and output streams and their types. The new API is also suitable to be provided in other languages, so I've created an initial Python binding for Tau. And then I spent some time on updating workflows for testing and building release packages of Tau with GitHub Actions. And I've solved all the issues with macOS build, and I'm working on a macOS release package. And currently I'm improving the API by adding a support for multi-line partial parsing and programmatic building of a specification before it is passed to execution.
Brilliant. Thank you very much, Tomáš. Always last but never least, over to you, Ohad.
So for the work about tables, I had some direction which I worked on, and it might have some promise. So now it's at the hands of Lucca to look into it further. Meanwhile, I continued working on the paper about the temporal extensions to the Tau language, how to have a temporal logic that the whole scientific community waited for, in a way that if we publish it, then hopefully we will get the recognition that we deserve from the scientific community, that we do have the best software specification language ever, much better, many levels better than anything that existed before. And during this work, I also discovered new results, which makes the algorithms even better. And yeah, that's basically all.
Amazing stuff. Thank you very much, Ohad. And thank you to all of you for tuning in. As always, do follow us on our socials, but don't just follow us, tweet at us, get involved, participate in these conversations. We are there. Yeah, we look forward to hear from you. So on X, that is Tau_net. On Telegram, that's TauNet, all one word, TAUNET. And on Reddit, that's TauNet, AGRS. Thank you very much. Cheers. Bye.